Confidence intervals for slopes. What could be so hard? Let's talk about it. Hi, I'm Aaron Hayes. I teach AP Statistics, and we're talking about the last two sections about slopes of least squares regression lines. So we're going to talk about how do we do confidence intervals today, and then we'll talk about how to do significance tests tomorrow. So we're going to jump right into it. It's really not terribly different than what we've done before. It's just a little bit goofy in terms of where we got to get stuff. So if you saw the last one where we were talking about sampling distributions of slopes, same data. And what we're going to be doing in here, I'm going to zoom in just a touch so we can see a little bit. So over here, we have our line of best fit. And again, that's coming from running of stuff. And this is going to be stuff that you can either run on your calculator, you can get out of Statlet, a whole bunch of different places. So we've got the score, predicted score is going to equal 85.95, which would be like the original score if you were row 0 minus 1.517 times the row. So our slope is going to be a negative 1.517. We have our standard error over here. And again, that most of that is coming from data. If you remember from the last video, they will actually give you that information there. And so then some of the question was, does it, if I were to take a different random sample of 30, would I come up with the same slope? And the answer is, of course not, because you're going to be mixing things up. Every random sample is going to have a unique least squares regression line and slope. Okay. From there, we have some parameters. The parameters obviously is going to be beta, which is going to be the true slope of the least squares regression line, and we're going to do it, and the statistic over there that represents the parameter is the negative 1.517. Now again, remember, we're measuring that in points per row. Every row you're moving back is going to get less than that. Now there are 5 conditions to check, and we use the first letters of them, and it's going to spell out liner. The first thing we have to do is we have to worry about the scatter plot has to show a linear relationship. That's not usually too terribly hard. And again, most of this will be given to you in a problem. The residual plot doesn't have to have, shouldn't have a leftover curve pattern. So here's the residual plot. And again, there's nothing there. Independent, we're not sampling here. So we don't have to worry about the replacement. Every observation is independent. So we're okay on that one. Normal, dot plot of the residuals. And again, remember, you don't want to see any skew in that. You can also look at how the dot plot falls out and see if there's any outliers or significant skew on that. We don't have that. Equal standard deviation. The residual plot does not seem to show a clear sideways Christmas tree pattern. Okay, so what that's going to end up looking at is that you're going to end up seeing something that looks a little bit like, I don't even know if I can get this, something that looks a little bit like this or the reverse. Okay, so it's not going to get more and more narrow into things. And then last but not least, the randomness. The teacher used random assignment to put everything. Okay, so that, again, LINER, and you can see that over here. And again, most of this data will be given to you because they don't want you to waste time having to type all the data in, run all the tests, et cetera, et cetera. So to construct the intervals, as usual, we've got the point estimate plus or minus the margin of error. And then from there, we also have, what's going to end up happening is we're going to use B because we're looking for slope. We're going to use T star because we're not doing proportions, which would be for Z. And then we're going to use the standard error for B. That will also be given to you, if you remember from yesterday. Now for degrees of freedom, we're going to go n minus 2. We've got 2 variables, so we're going to peel it back from there. At least that's how I always remember it. And then you're just going to plug stuff in. And you're going to go from, you're going to just plug stuff in. So in this case here, I've got my B value of a negative 1.517 points per row, plus or minus. There's my T star score, and then 1.33 from the computer printout. So that gives me a confidence interval from a negative 4.24 all the way up to 1.21. Your conclusion is going to sound really kind of familiar. We are 95% confident that the interval from negative 1.24, or it can be from negative 4.24 to 1.21 points per row, captures the true slope of the least squares regression line for our population. Now, it's important to go through because we haven't had context up to that point. Make sure that you talk about what row is, that rows are your X value, and your exam score is for Y. They may also ask you, just like regular confidence intervals, they may ask you to go ahead and follow up. Hey, there's, is it plausible? This is not plausible because obviously 0 is inside the interval. So we have positive, we have negative. So we don't know if this is an increasing. Are you having a benefit from sliding back a row or not? And according to our confidence interval, there's no data. We can't figure that out. So that's all the basics of a situation of how you would run through a problem. Okay, we'll formalize it a little bit, but again, a lot of it's just going to be a matter of, can you handle the information that they're giving you and then going from that. Okay, so make sure that I'll link this side over here, subscribe here, link to the next videos over here, and we'll talk to you soon.